Professor P.N. Ghosh Milestone lecture by Professor Wuqiang. The topic is capacitive touch sensors for robots. Touch sensing is important for a robot to interact with their external environment. Currently, most robots can handle an object at a specific location and they are vulnerable to an unknown object and or unknown environment. Touch sensors play an important role in the interaction between a robot hand and an unknown object because touch sensors can provide necessary information on touch detection and feedback control. Among various touch sensing techniques, capacitive sensors have gained popularity due to their simple structure, high sensitivity, low power consumption, quick response, wide dynamic range and low cost. At the University of Manchester, the Joint Research Laboratory of Touch Sensors for Domestic Robots was established in 2019, working with a company in Beijing. In the past few years, various capacitive touch sensors with different structures and different materials for different purposes were developed at this laboratory. In particular, a unique design of a capacitive touch sensor is developed that can sense in three different modes: proximity sensing, touch sensing for material identification, and 3D force sensing. A representative diagram of the sensor is shown in the following diagram. The sensor consists of an external conductive rubber layer which can be used as an excitation electrode or detection electrode or as an external screen, a middle non-conductive rubber layer and a rigid printed circuit board with four sensing electrodes. The four sensing units can be combined to provide touchless proximity sensing as shown in the following diagram. The dome structure can perceive an applied external force in varying directions and magnitudes. By measuring capacitance from the four electrodes, the external force can be measured in 3 dimensions. The diagram shown afterwards may give some idea about its function. In recent years, capacitance-to-digital converters (CDC) chips have been developed rapidly, such as one from Analog Devices, another from Texas Instruments, and another from Silicon Labs. They are all small in size and can measure very small capacitance down to femto-Farad level. The cost is also very low. Therefore, the CDC has gained popularity. This laboratory has developed a digital analog hybrid chip as shown in the following photograph. It consists of a 24-bit high speed and high precision CDC, a 32-channel multiplexer, an ARM microcontroller and a router, facilitating collaborative capacitance measurement across multiple chips as shown in the following diagram. In addition, it supports a 24-bit address event representation AER for online neuromorphic computation, enabling efficient and low power operation to implement artificial intelligence functions. This chip has been integrated with our capacitive touch sensor. For more specific applications like promptly responding to sleeping, the signals from the touch sensors can undergo direct analysis and processing within the chip rather than transmitting information to a host computer. Two robots in our lab have developed equipped with capacitive touch sensors and dedicated chip. The following figure shows a NAD2 robot from Nyon, France. And the next figure shows an UR5 from Universal Robots of Netherlands. With capacitive touch sensing, both robots can catch up with either a hard heavy object or a soft light object. The following figure shows that the UR5 can catch up either a glass of cup full of water or a piece of tofu which is similar to soft as cheese. Without sleeping, sensing by the capacitive touch sensor, it is not possible to catch a piece of tofu by a robot. The developed capacitive touch sensor and the dedicated chip are being considered for many other applications such as intelligent functions for cars, for example, automatic car wipers, consumer products, medical surgery, and elderly care. Also, it is possible to develop a very low cost electrical capacitance tomography ECT device for industrial application. Here ends the brief account of the lecture delivered in previous session. The question and answer session is to follow now.
Thank you very much. I think everything has been discussed by Professor Young, and now it is time for questions. I would invite questions from the audience. If you have any question, please. Thank you.
Professor, your lecture was really very, very lucid and easy. Very simple but very interesting. I have a question. Normally in the airports, when we travel, so many times I have been stopped because of a long rod in my left leg. But no, I have still not seen in Indian airports at least fencing of ceramic objects. Is it commercially made already? Is it commercially available in security checks in airports?
No.
As yet? Not yet.
No. You know, in the UK, manufacturing moved out from the UK. We can have many ideas, we can make even prototype, but it's very difficult to commercialize. That is why you can see all those commercialization happening in China. I have a joint project with a company in China. We do research, they commercialize. This is a big weakness in Europe.
Okay. Why I am saying is this, from the security point of view and the present status of security and risks, this could be a very big opportunity to use this this is invention. To commercialize it.
Also, I did this work 20 years ago, like a shoe scanner, even bottle detector, like a ceramic knife detection. All those work have a very big opportunity to commercialize.
Yes.
As an academic, you have to choose. Either you do something scientifically leading, or you do something simple, you can make money. You have to make a choice.
Because, as you said, the ceramic knives are very common today. Even kitchen knives are ceramic these days.
It is.
And it could be very dangerous. It could be very dangerous.
That's true. That's true.
Thank you. Thank you very much.
Any more questions?
Capacitor touch sensor and with some exciting application. My question is related to some small spectrum of this lecture, which is related to sports, in particular football. In football, suppose I take for example England versus Germany, and the ball is in motion and it is touched by the football player and it is approaching, and every motion of the ball is captured in some way. Possibly this sensor you already covered here. My question is related, after the motion is detected by your sensor, how the signal is transmitted to some control room?
That is a very different. You talk about how can you measure the ball itself. You need remote sensing. You need transmission, communication. That is a different topic. With the sensing itself, is simple. Communication and telecommunication, that is the big task.
Yeah, thank you for your answer.
It is possible, because I work on tomography. If you have multiple receivers, you can locate exactly which sensor in what position. Not only the ball, but the ball rolling, how this ball movement. It is possible to do this. But again, you need a good communication.
I had a question. We had a question we were discussing as you were showing us the use cases across industries that, maybe slightly on the lighter side, but would there be a vision? You talked about this being a research from 20 years back and this is still developing. So would there be a vision when all of this will gradually move into an artificial intelligence enabled state where instead of waving hands through proximity sensing, we will be thinking in our minds and some of these sensors will work and give similar functions as we were seeing in the use cases?
Okay. As an academic, I don't encourage people, at least myself, I never repeat others' work. If I show a piece of work, you will see this is totally different from others. What I like, if you like working in this area, what I like to encourage is after this sensing, how to make use of a new technique like machine learning, implement AI functions. Actually, that is part of work I'm going to do with my students. I just recruit 2 students working on this topic as a machine learning for data processing. I talk about capacitance sensor. I talk about tomorrow. I will talk about tomography, is electrical capacitance tomography. With the electrical capacitance tomography, we can generate huge amount of data. We worry where we can save so many data. That is the basis. How can we use machine learning for further data processing? Tomorrow I will talk about. I think further work, like post data processing by implement AI functions. That is a good direction.
Thank you, Professor. We look forward.
How far it has been put to use in railway, detecting the infringement stone on the track is anywhere it is in commercially used. In the railway, in detecting the stone on the track, has it been put to use anywhere in the world in any railway system?
Okay. We are discussing with authority in China. The problem with the railway, in particular, in a tunnel, in an entrance exit of a tunnel. Nowadays, they use a camera. They have a camera to monitor those entrance to see if anything strange in entrance, in particular with the falling stone. The problem is with the camera, they can't tell exactly what material it is. You have a plastic bag, you have a rubbish bag, you have something else. After days, you wouldn't tell what material it is. If that is dangerous object, that is a falling stone. With this technique, if we have a certain area, we have electrodes alongside of rail track. Now we can tell what material it is. That is the big difference between this technique, the capacitance measurement, and video camera. The video camera cannot tell what material it is. That is a big difference.
Okay, thank you, sir. Any more?
Yes, I have one question. Sensitivity wise, how fast is this sensors?
To what? The sensitivity?
Yes. Sensitivity wise, how fast these sensors are?
Okay. That is a pure academic topic. If you have 2 electrodes so far away, the sensing depth is about this distance. That is called the fringe effect. When you have 2 electrodes, the field will generate like an arch is about this distance. That is a sensing depth. The sensing depth is not far. If we need the longer range of measurement, you need to combine with other sensing technique, such as ultrasonic, with other technique. This with the capacitance is closer, is more sensitive. That is a physical phenomenon. So because today I talked so many new topics, new applications, I guess you are interested. Maybe in future you can work with us together to some aspects, some applications.
Sir, I have just a very small query about the since you have asked about you are talking about the capacitive sensors. I have seen a lot of applications where different kind of dielectric medium is varying, and those are temperature dependent dielectric medium where inside the room or any kind of thermal variations is over there. They are affecting the dielectric medium of in case of capacitive sensing. So what can be the solutions with this kind of, as you have mentioned, the capacitance to digital conversion like principles. So what that can be done in case of selecting different type of dielectric medium for capacitive sensing?
Obviously, capacitance is a function of permittivity. With a different material, you have a different permittivity. What currently we do, when we have our robot arm, we move to close. When just we touch the material, now with the different material, we have a different capacitance measurement. Of course, between this distance and material, this is a crosstalk each other. But before, you have just a touch, you wouldn't tell what material is because you have another parameter, that is a distance. So you need to make sure this distance is exactly the same for different material. Now you have a different capacitance measurement. And then you have your database, such as CNN or SNN. Now you can tell. You need to train your network so that you can tell different materials.
I think it time is up now, and you have enough of questions. Mr. Yang has answered them thoroughly well. So I conclude this session, thanking the Yang and thanking the audience, members of the audience.
Thank you. Thank you very much.
Thank you so much, Professor Potronovich and Professor Yang, for this wonderful session, and kind of responsible from the audience is exactly what we expect.